Hello students, in this video we are going to discuss about the expressing concentration of solutions. If we consider the following solutions here, that is actually colored solution, if the question is asked which solution is more concentrated. So definitely the lighter one, you can say that it is diluted one, and the more thicker colored you can say that it is a concentrated. So here you are expressing the concentration on the basis of the thickness of the colored which is added to the water. That is a more colored, more thicker colored one is the concentrated and the lesser one is the diluted one. So that means we are expressing the concentration here on the basis of the quantity of the solute which is added to the water. So that type of description, that is actually qualitative description of the concentration of the solution. That means qualitatively we can say that the solution is dilute. The solution is dilute because relatively here have very small quantity of solute. On the other hand, it is called as the concentrated one. Why? Relatively very large quantity of solute is found in this. So here we are expressing the concentration only on qualitatively based. So this is a qualitative description of the concentration of the solution. But in the real life, these kinds of description can add a lot of confusion and there's need for a quantitative description of the solution. So the quantitative description of the solution, this can be done in a several ways. So there are the several ways by which we can describe the concentration of the solution quantitatively. So these are the formulas which we can use in order to describe the concentration of the solution. And we are quite familiar with these formulas as you have already learned these formulas in 11th standard. That is, the concentration can be represented in terms of mass percentage, in terms of volume percentage, mass by volume percentage, parts per million, mole fraction, molarity and molality. So just recall these terms, the formulas which will be used in solving the different problems which is given in the textbook. So first we'll be discussing about the mass percentage, that is mass by mass we can say. Mass percentage of a component is equal to the mass of the component in the solution by total mass of the solution into 100, because here we are taking in the terms of percentage, that's why it is multiplied with 100. For example, if we say there is 10% glucose in water by mass, 10% of glucose solution in water, what it means that is the 10 gram, what is the mass of the glucose, that is 10 gram will be the mass of glucose divided by what is the total mass of the solution, because it is 10% means here should be 100. Okay, so then only we'll be getting 10%. So when 10 gram of glucose is dissolved in 90 gram of water. Why it is 90 gram? Because total mass, that is mass of solute and solvent, will be 100. So 10 gram is the mass of glucose, that is solute. So 90 gram will be the mass of water, that's why it make 100. So what it means 10% of glucose in water by mass, that means that 10 gram of glucose is dissolved in 90 gram of water, that is resulting in the 100 gram of solution. So whenever it is given that is 10% of salt solution means that is the 10 gram will be the salt and 90 gram will be the solvent in whichever it is dissolved. So if it is given that is 25% of glucose solution in water. What it means that 25 gram of glucose, that is the solute, is dissolved in 75 gram of water. So it is very important because in problems we'll be getting usually in the terms of percentage. So the next one we have a volume percentage. Volume percentage, just like a mass percentage, here we are taking instead of in mass, we are taking in terms of volume. That is, volume percentage of a component is equal to the volume of the component divided by total volume of the solution into 100, because it is taken in the terms of percentage. The example is the 10% ethanol solution in water. Now ethanol is actually liquid in state and water is also in the liquid state. So instead of taking mass, we are taking in terms of volume here. So the another unit which is commonly used in the medicine and pharmacy is the mass by volume percentage. It is the mass of the solute dissolved in 100 ml of the solution. That means how much is the mass of the solute taken in order to dissolve in the solution divided by total solution. The mass, the volume of that solution will be together, it makes 100 ml. Next is here the example, that is 10% NaCl solution means that 10 gram of NaCl are dissolved in 100 ml of the solution. It is very important to note 100 ml of solution means solution including the solute and the solvent. Next is the parts per million. That is equal to the number of parts of that component divided by total number of parts of all the components of the solution into 10 raised to power 6. These actually used in order to find out the concentration in which the solute is present in the trace quantities, and it is convenient to express the concentration in the terms of parts per million. It is also, in short, we can write it as ppm. Next is a mole fraction. It is a very important point, the concentration in terms of mole fraction. Mole fraction, that is the for a component is equal to the number of moles of the component divided by total number of moles of all the component. Here we are taking the moles of the component, that is number of moles of the component. If the component A, mole fraction of component A is equal to the mole fraction of component A divided by total number of moles of all the component. Let it is a binary solution. Consider this one as a binary solution. Binary solution means in which two components will be there. One of the component is A and the other one is the B. So what will be the mole fraction of A component? That is XA is equal to Na upon Na plus Nb. And if we want to find out the XB, how we find out? That is Nb divided by Na plus Nb. So that means the denominator is actually the total number of moles of all the component. So here the mole fraction that is can be, when we make the sum of the mole fraction of all the component, it will be equal to 1. So in the case of binary solution have only two components A and B. So the two mole fraction here, that is mole fraction of A component, when you make the sum of the mole fraction of A component with the mole fraction of B component, it will give 1. If it's a quaternary solution, that means it have 4 components, and let I make it as A, B, C, D. If there are 4 components, so the mole fraction of A component plus mole fraction of B component plus mole fraction of C component plus mole fraction of D component. So the sum of the mole fraction of all the component in the solution must be equal to the 1. So it is very important to note that whatever the number of components is present in a solution, the sum of the mole fraction of all the component will be equal to 1. Next is the very most familiar term to you, that is molarity. Molarity, it can be defined as the number of moles of solute dissolved in a 1 liter of solution. So here volume of the solution is taken and this is number of moles of solute. So how we have learned this one, that is number of moles of solute. Here the solute is taken as B. Letter B is used for the solute and A for the solvent. So the number of moles of solute dissolved in 1 liter of solution, that is volume is taken in 1 liter. But if it is in the ml, we have to multiply with 1000. What about the unit? The unit is actually for this one is mole per liter. That is the unit for molarity. And we represent the molarity in the capital M. Next is molality. Molality will represent in small m. It is number of moles of solute dissolved in 1 kg of solvent. So how we write this one? Number of moles of solute dissolved in 1 kg of solvent means the mass of the solvent. So we'll represent the mass as mw. So mass of solvent, and the solvent that is represented by letter A, and this is actually in 1 kg. If the mass of the solvent in grams, we have to multiply with 1000. What about the unit? The unit of molality is, that is mole per kg is the unit. And we represent the molality in small m. So these are quite familiar to you, molarity and molality. Here we have used the number of moles of solute, we represent it as NB. NB, that is number of moles. How we expand it? Number of moles can be find it out by the formula, that is given mass by molar mass. So that is NB is equal to WB by MB. So this is very important formula which we have already learned. Let us do a problem related to the molarity. It is a text solved problem, that is example 2.2. Calculate the molarity of the solution containing 5 gram of NaOH in 450 ml solution. So it is very clear formula, that is the mass of, that is a given mass of NaOH. So first you have to identify which one is actually solute here. NaOH is the solute. So that we can represent it by the letter B here. So NaOH is a solute and solvent is not specified here, but the volume of the solution is represented as 450 ml. So first of all, we have to use the formula of molarity. But in the formula of molarity, what is the formula for molarity? That is capital M is equal to NB by V. V is given to us, but NB we have to find out. What is NB? That is NB is equal to the number of mole is equal to given mass by molar mass. So given mass is actually 5 gram. 5 gram is the given mass. So 5 divided by, and what is given to us? It's a formula is given as NaOH. So we have to find out the molar mass. That is when you find out the molar mass by formula, we'll be getting the molar mass, that is 40 gram per mole. So here first we have find it out the number of moles, that is NB is equal to 5 divided by 40. 5 gram is the given mass, 40 gram per mole is the molar mass of NaOH. So when we solve this one, we will be getting this much number of moles. Now we will be applying the formula for molarity. So molarity, the number of moles, the value substituted here, and 1000 we have multiplied because here the volume of the solution is in ml. That's why we have to multiply with 1000. And when you solve this one, we will be getting 0.278 mole per liter. Here capital M is actually the unit which is representing for molarity, that is mole per liter. So this is what a very simple problem which is given in the textbook. Next is a problem that is also a text solved problem, that is example 2.3. Calculate the molality of 2.5 gram of ethanoic acid. The formula is given here. in the 75 gram of benzene. So as I told you, first we have to identify the solute and the solvent. So here ethanoic acid is actually dissolved in the benzene. So this is the B component, that is the solute, and benzene is the solvent, that is the A component. Here the quantity, that is a mass, is given. The mass of solute is given 2.5 gram and 75 gram is the mass of the solvent. Now we can make the use of formula, that is molarity is equal to, how we find out molarity? Molarity is equal to number of moles of solute dissolved by in 1 kg of solvent, that is WA. But here NB we have to find out what is NB. So NB first we have to find out NB is equal to WB by MB, that is given mass by molar mass. What is the given mass of a What is the given mass here? That is 2.5 gram is the given mass. That is NB is equal to WB by MB, where WB is the given mass, that is 2.5 gram. And what about the molar mass? Because formula is given to us, we can find out the molar mass. That is by using the formula. So we will be substituting the value of molar mass here. So that is actually 60. So we'll be solve this one, we'll be getting the number of moles, that is 2.5 gram divided by 60, that is equal to 0.0417 mole. Now we'll be substituting this in the formula, that is number of moles, we have find it out, divided by the mass of the solvent, that is 75 gram of benzene, which is given to us, but it is given in grams. We have to represent this in the terms of kgs, that's why we have to multiply with 1000. So when we solve this one, we'll be getting 0.556 mole per kg. So this is the problem, 2 problem which is given, and some in-text questions are also related to the concentration is given in the textbook. So all of you solve these problems also. So this is all about this video. Have a nice day.